Hello, this is giulia.burchi and welcome to this workshop. Let me introduce my company and myself. Decision Brain is a high-tech company that creates advanced analytic solutions. We focus on workforce, manufacturing, and logistics. Our customer base is made of market leaders from all over the world. We are based in France, Hong Kong, and the United States. I am the product manager of Decision Optimization Center at Decision Brain. Decision Optimization Center, DOC, is a platform that reduces the effort, time, and risk associated with creating tailored solutions. DOC is an IBM product, and together with IBM, we delivered a new version of IBM DOC in 2019. This inherits all the good ideas of the old generation DOC, plus the secret sauce of Decision Brain's successful solutions. All this in a brand new platform based on modern and open source technologies. DOC bridges the gap between mathematical models and fully blown applications for business users, and it does it in less than 15 minutes. And this is what I will prove you today. Today, I will integrate a Python model into a fully blown application. I will build a UI for it. I will deploy it on the cloud and make it available for business users. And this will take me less than 15 minutes. I have built a data model and a Python algorithm to solve a simple capacity planning problem. I want to plan a set of activities over the shortest time span possible, taking into account the available resources and the activities precedences. The data model is described in JDL, a language by JHipster. Using a JDL model as an input, I can generate a DOC application writing one single command. DOC automatically generates the code for the different parts of my application and the configuration files for the build. I can now build the application with another single command. I just generated and built a DOC application, and this took just a couple of minutes of my time. I can now integrate my Python code into the generated application. The code must be inserted into the predefined engine Python file. This file contains three parts: the dictionary where I can find my input data frames, a placeholder for my engine code, and the dictionary that I will use to store my output data frame. I will retrieve the data I need from the input data frame dictionary. Each data table is associated with a data frame. I extract the data from those data frames in the appropriate structures for my modeling engine. I can now define the decision variables, the constraints, and the objective function. Then I can call the solver and write the code to extract my solution. My engine is ready. I can use the predefined test environment to validate it interactively with data snapshots. Once validated, I can encapsulate it into a custom worker so that it will be available once the application is deployed. To do so, I execute the predefined configuration command that will create the proper container. My Python worker is fully integrated, and this took me less than 5 minutes. I will now deploy my application locally on my machine using the Docker Compose files that I generated a couple of minutes ago. I will use the Docker Compose command to run all the generated services: the optimization server, which handles the CPU-intensive computation, the backend service, which is used to run short data processing tasks, the execution service, the web UI, the data service, and the scenario service. The application deployment through Docker Compose took me about 5 minutes. I can now open the deployed application on the browser. It provides a default login screen, and then it gives me access to the scenario home. This is where we'll manage all my scenarios and where I can start working on my data and my UI. My web UI is empty for the moment. I have to create a scenario and some dashboards. DOC applications can be integrated with external databases, but in this case, I will simply upload an Excel file. I just created a new scenario that contains the data from the Excel file. Now I want to display it in a dashboard. I create a new dashboard and I name it Data Explorer. And I add one of the widgets proposed out of the box by DOC. I have now access to all the information in my scenario, and I may want to reorganize them so that it is more user-friendly for my business users. I can group in one folder the input data, so the country, the plants where the activities are performed, the activities themselves, and the resources they require. In a second folder, I will put the plan, so the solution of my Python model, and some KPIs. And finally, I will hide the information that my users don't need. In a couple of clicks, my Data Explorer dashboard is ready. My users will easily navigate the data through this widget. Now I want to build a dashboard to display the solution. I create a new dashboard to display the Gantt chart. In the Gantt configuration, I will select which entities I want to display from my original JDL data model. I want to display the events performed by the resources, and the events are a representation of the schedule entities. My Gantt is ready. I'll make it fit in my dashboard, and I will zoom in so that it's more visible. I also add a chart that will give me insight into how different resources are being used across time. I will call it resource usage. It takes the data from the resource usage per day table. This table is computed at the end of the engine processing. I want to display the resource usage day by day. I create a bar series to represent it. I name it resource. Each column will display the sum of the number of hours used per each resource, and I display the resource name. Here is a preview of how the chart will look like. By saving, I will add this widget to our dashboard. I also want to display a second KPI, the time span. The time span is the number of days needed to complete all the activities. I made some space in my dashboard and I can now add this last KPI. My dashboard is almost ready. I will just add a button to launch the optimization and I'll be done. I'll make some little adjustment to leave more space to the Gantt chart and I'm done. I created a simple UI for my Python model in less than 5 minutes. Now I need to deploy it on the cloud and make it available for my business users. The deployment of a full application can be tricky. It usually takes time and requires specific skills. DOC fully supports this phase thanks to modern technologies like Docker and Kubernetes. When generating the application code, DOC also generates the predefined Helm charts that can be used to deploy in different environments. To deploy my application, I will use the Helm command with those charts. After a few seconds, the pods are running and the application is ready to use. The cloud deployment cost me one command, a matter of seconds. Let's take a look at the application I generated through the eyes of a business user, a planner in this case. So as a planner, I would log in into my new application and I would check my plan. I may like to simulate how the plan would change if I had less available resources. In the resource usage chart, I can see that the resources M1 and M2 are on the critical path. What would happen if I had less resources available? So I will duplicate my scenario, rename it What If, and I will reduce the head count for the resources M1 and M2. Back to my Gantt view, I can run my Python worker and see how the time span will change. I can check my running job and access the log in real time. I can access the list of all the jobs that I've run. I can easily spot failures, check which step failed, and retrieve the input and log for debugging. My Python task is completed, and I can check the new plan. Switching scenario, I can easily compare my two solutions. As expected, the time span has increased. My time span was 401 days in my initial plan, and it would increase up to 795 days if I had less available resources for M1 and M2. So I've been of my word. I leveraged my Python model and my data model to build a full application for business user and deploy it on the cloud in less than 15 minutes. So that was a very easy example. We all know that creating a real-life application doesn't take 15 minutes. But how long will it realistically take to you to build an application based on your optimization model using this technology? Maybe a few hours, one day. Still, it's nothing. And most importantly, you don't need DevOps skills to deploy, and you don't need front-end skills to build a UI. So this is the real strength of our platform. We want to create a technology that allows you to focus on your core competencies and meanwhile allows to bring your model at the business user's fingertips. If you want to learn more about Decision Brain or about our platform, you can look for our website. It's in the link below. And don't hesitate to reach out directly to me for any feedback on this video. I am interested in understanding what are the bottlenecks you're facing in creating your solutions. So I hope to talk to you soon, and goodbye.